The solar system may soon go back to having 9 planets, but don't rejoice yet, Pluto fans. 10 years ago, Pluto was downgraded to the status of a dwarf planet after a team of astronomers led by Michael Brown of Caltech, Chad Trujillo of the Gemini Observatory, and David Rabinovitz of Yale discovered Eris, an object that was larger than Pluto at the far edge of our solar system. These discoveries led the International Astronomical Union, IAU, to revise the definition of a planet and place Pluto into a new class of dwarf planets, dropping the official number of planets in our solar system from 9 to 8. Now, a recent paper from Caltech astronomers Konstantin Batygin and Michael Brown has proposed the existence of an undiscovered planet far out on the edge of the solar system. These findings have generated a huge amount of interest in and questions about a potential 9th planet. While the thought of discovering something so major about our solar system may seem quite surprising, astronomers have actually spent the last 3 decades cataloging a whole host of strange and exotic phenomena on the outer edge of our solar system. The concept of a new planet may not be as totally out there as it seems. The quest through the centuries for Planet X. While the nature of our solar system has been a subject of controversy throughout history, the existence of the classical planets has long been established and beyond question. Mercury, Venus, Mars, Jupiter, and Saturn could be observed with the naked eye, and astronomers had tracked their movements since 1000 BCE. This state of affairs held until 1781, when the British astronomer Sir William Herschel reported that he had discovered a new comet using a telescope of his own design. Other astronomers immediately began to study the object and soon realized that what Herschel had discovered was in fact a new planet, which was christened Uranus, in the following decades. The French astronomer Alexis Bavard used Newton's laws of motion to predict the orbit of Uranus with great accuracy and quickly discovered that the actual orbit of Uranus was out of sync with his predictions. One major cause of discrepancies between the predicted and actual orbits of an astronomical object is gravitational perturbation, in which the observed orbit of the object deviates from predictions because of the gravitational pull of another object. Spurred by these findings, another French astronomer named Urbain Le Verrier announced the discovery of the planet Neptune in 1846, expanding the solar system once again. After remaining static for over 6,000 years, scientific understanding of the planetary makeup of our solar system had become unstable and ripe for discovery. Shortly afterwards, a wealthy businessman from Boston named Percival Lowell decided to turn his attentions to the stars. In the 1890s, he built an observatory in Arizona and became involved with multiple astronomical endeavors, such as attempting to find proof of the existence of intelligent life on Mars. Although his efforts in that area were ultimately unsuccessful, Lowell also managed to popularize the theory that an uncharted planet was orbiting on the farthest reaches of the solar system and that the existence of this planet could explain discrepancies in the orbital patterns of Uranus and Neptune. Lowell coined the planet Planet X to reflect its unknown nature and spent the rest of his life fruitlessly searching for it. In 1930, 14 years after Lowell's death, Pluto was discovered by Clyde Tombaugh working in the Lowell Observatory. At first, astronomers thought Pluto was at least the size of Earth, as it needed to have enough mass to affect the orbits of Neptune and Uranus, and assumed that it was the missing Planet X of Lowell's theory. Subsequent work into the 1970s led to more accurate estimations of Pluto's size, about 0.2% the mass of Earth, discounting its identity as Planet X. The Planet X theory was pushed aside and largely ignored, until now. Going deeper into space, beyond planet Neptune, Pluto resides in an area of the solar system referred to as trans-Neptunian, meaning that it orbits the Sun at a distance farther out than Neptune. That is, from farther than 30 times the distance from the Earth to the Sun, or 30 astronomical units, Figure 1. Here, on the frontier of the solar system, lies a vast jumble of icy bodies known as trans-Neptunian objects, or TNOs for short. The past 30 years have yielded an abundance of previously unknown TNOs. As of now, the International Astronomical Union's Minor Planet Center lists nearly 2,000 objects. Although many of these objects are small and similar to asteroids, some can be quite large and are classified as dwarf planets, like Pluto. Since 2004, the IAU has defined a planet by 3 criteria. It must orbit the Sun, be large enough to be shaped into a spherical object by gravity, and clear the neighborhood of its orbit, meaning that there are no objects of comparable size and mass around it. Dwarf planets are categorized as such because they fail to fulfill the third requirement of clearing the neighborhood. For example, because Pluto's moon, Charon, is over half its size, Pluto is considered a dwarf planet that has not cleared the neighborhood of its orbit. Therefore, Pluto is no longer counted as one of the planets of the solar system. The identification of TNOs and other extremely distant objects have laid the groundwork for the potential discovery of a new member of our solar system. In the past few years, astronomers have observed that some distant TNOs share an uncommon property, their arguments of perihelia cluster around zero. In layman's terms, this means that these objects are level with a plane of reference centered on the Sun, labeled in gray in Figure 2, when they reach their perihelion, literally the point of closest approach to the Sun. This observation is particularly strange because it is common across all of the 13 observed TNOs. Even though these angles would be expected to change randomly over billions of years due to gravitational effects. Extensive mathematical modeling has shown that this is not simply due to observational bias, but that this property should exist for all distant TNOs. To account for this effect, multiple theories have been put forward, including the idea that a large, planet-sized object is affecting the orbits of these TNOs. Planet 9, a new piece of the puzzle. Recently, Caltech astronomers Konstantin Batygin and Michael Brown have expanded upon that theory by showing that the orbits of distant TNOs cluster physically in space and that the orbital alignment of TNOs is highly unlikely to have arisen by chance. Using mathematical simulations, Batygin and Brown determined that a massive object orbiting at least 200 O away from the Sun could explain the orbits of TNOs. In comparison, Pluto is roughly 50 O away from the Sun at the farthest point of its orbit. The astronomers propose that the strong gravitational forces exhibited by this object interacts with TNOs through a process called resonant coupling and causes the clustering of perihelia that has been previously observed. This object is expected to have a highly elliptical, non-circular, orbit and should be roughly 10 times the mass of Earth. Batygin and Brown's research, in combination with the work of other astronomers, provides strong evidence for the existence of a distant, massive planet lying far beyond Neptune. We may be on the verge of expanding the set of planets in our solar system to include a new member, Planet 9. Mysteries of the solar system yet to be uncovered. As of now, Planet 9 only exists on paper. Much more research is needed to confirm that astronomical observations support the existence of a new planet. The work done by Batygin and Brown predicts that a distant planet would affect an entirely new class of TNOs with highly inclined orbits. The discovery of these objects would yield further evidence that Planet 9 is real. Even then, the sizable task of directly identifying the planet itself remains. Although Batygin and Brown provide a set of predicted orbits for Planet 9, the area to be searched is enormous, and the planet is so far from the Sun that it barely reflects any light. In fact, there are nearly 4,000 asteroids known to be at least as bright as Planet 9 is theorized to be, making it very difficult to detect with the currently available telescopes. It took nearly 40 years from when the existence of Neptune was first predicted to when it was directly observed. Although astronomical technology has made huge advances in the past 2 centuries, we may still be in for a long wait. Searching the furthermost reaches of the solar system has led to the discovery of thousands of objects that orbit the Sun and led to new advances in our understanding of planetary formation. If anything, these recent findings are a good reminder of just how much there is left to discover as we explore our place in the stars.